Hey guys, it's Ms. Jaco. I'm here to go over your lesson 16 concept development. For this concept development, you are going to need a lined piece of paper and I guess any piece of paper will work, and a pencil to take notes. And you're going to want to use those notes to answer the problem set problems, because these questions are going to be very similar to the problem set problems or questions. So looking at our I can statement, it says I can solve word problems that involve money. So we're basically going to be taking all that new knowledge that we gained from lesson 15 and we are going to be applying it to word problems. So what we're going to do is I'm going to read this first one to you, and then I'm going to kind of release it to you, and I want you to try and solve it on your own. And then, so you're going to pause the video, work it out, and then you can play the video, and we'll go over and review or compare our strategies. Okay, so I am probably going to expect you guys to read these questions more than once to make sure that you are paying attention to what coins are being used, because that's going to determine the value of their, like how much money they have. And I'm going to probably want you to like draw out or like show me some kind of work as to how you are figuring out how much money they have. And yeah, so problem number 1, it says Joshua has $1 bill, 4 dimes, and 9 pennies. CJ has $2 bills, 2 quarters, and 3 pennies. How much money do the two boys have in all? Okay, so go ahead and pause the video and play it whenever you are ready to compare strategies and go over the answer. All right, so I'm guessing since you are now back, you are ready to go over the answer and compare strategies. So I'll probably show you more than one way to solve, just so you we understand that there isn't just one method. There's many different ways that you can solve math problems, and yeah, there's no just one way. So let's see. Joshua has $1 bill, 4 dimes, and 9 pennies. CJ has $2 bills, 2 quarters, and 3 pennies. How much money do the boys have in all? So I'm seeing in all. I'm seeing the two boys. So it looks like we're going to take CJ's amount and Joshua's amount, and we are going to add them together. So I want us to pay attention to what units or what coins we have here, because that's going to determine the value of our money. Okay, so it looks like Joshua has $1, 4 dimes, 9 pennies. 4 dimes, that's going to be 40 cents. 9 pennies, that's going to be 9 cents. So all together, you've got $1 plus 40 cents plus 9 cents. That's going to be $1.49. So I should probably put a J for Joshua. And then Christopher, or CJ, hi Christopher, if you're watching this, has $2 plus 2 quarters plus 3 pennies. So 2 quarters, that's going to be 50 cents. 3 pennies, that's going to be 3 cents. And then my $2 is just going to be $2. I'm going to add it all together, and I get $2.53. So now I'm going to add my $1.49 for Joshua's and my $2.53 for Christopher. So I'm going to add my like units plus my like units. So that means I'm going to add my $1 plus my $2, which gives me $3. And then I'm going to add my 49 cents plus my 53 cents, which is going to give me what? I'm going to do my work off to the side. And I get 102. So that's 102 cents. So if we think back to lesson 15, 102 cents is what fraction of a dollar. 102 cents is what fraction of a dollar? I'm going to move that over there. So 102 cents would be 102 hundredths of a dollar. Now, what do we notice here? We should see that we have more than one whole here because the numerator is bigger than the denominator. We have an improper fraction. So we're going to want to pull out the wholes. How many hundredths is equal to 1? 100 hundredths is equal to 1. And then we have 2 hundredths left over. So what does that mean for like our dollar amount? Well, 100 hundredths, that's like one whole dollar. And I'm going to take this dollar and add it on to the dollars that I already had. And I'm going to get $4. And my 2 hundredths, that's going to be the same thing as 2 cents. And so we turned this 102 cents into $1.02. So all that's left over from it is my 2 cents. Because I took 100 cents of it and turned it into this dollar here. So what does that mean for our answer? That means that Joshua and CJ have $4.02 all together. Okay, so that is just one way to solve the problem. I kind of just like added everything together individually and then took my two answers and added those together. I'm going to show you another way that you could have solved this problem. Okay, so another way we could have solved was finding out how much they have all together. So we found that Joshua had $1.49 or $1.49. And CJ had $2.53. So if you can really think flexibly about this, we can think, oh, 49 cents plus 53 cents. You might already realize that we're going to get more than 100 cents. So you could break this apart into 47 and 2 cents and think, I know 47 cents plus 53 cents is going to give me 100 cents. So I can kind of rename this as $1.02 plus $2 100 cents. Because it's kind of like I took this 47 cents and added on to the 53 cents I already had to make 100 cents. So now I'm thinking $1 plus $2, which is, plus my 100 cents, which is like another dollar, because 100 cents is equal to $1. I now have $4 plus 2 cents, which gives me $4.02. So that's just another way of doing it, where you try and make the whole number, like make your wholes first, and then add everything together. Whereas this strategy was kind of just adding together your parts first, and then adding those parts together to get a whole. All right, so I think we're ready to move on to problem number 2. All right, so this is our problem number 2. We're going to do the same thing. I'm going to kind of let you guys try and solve it on your own, and then we're going to compare answers. So this problem reads, Miss Forkner needs $8.47 to buy a book In her wallet, she finds $5, 7 dimes, and 6 pennies. How much more money does Miss Faulkner need to buy the book? So make sure you are reading the question again to really make sure, like, what coins are we using? What words are being used in the problem? Like, think, what is it asking us to do? Try and figure out if there's something that you can draw to help you solve, and go ahead and pause the video and play it whenever you're ready to go over the answer. All right, so I'm going to read the question again. It says, Miss Faulkner needs $8.47 to buy a book. In her wallet, she finds $5 bills, 7 dimes, and 6 pennies. How much more money does Miss Faulkner need to buy the book? So when I see the words, how much more money does she need, I'm thinking she doesn't have enough already to buy the book. So it's asking, if she did want to buy the book, how much money would she need to add on to the money she already has in order to be able to afford it? So I'm thinking, if I'm thinking about this like as a problem, I'm thinking the money she has plus what is going to give me the money, or give her the money she needs to buy the book. So she has some money. How much more money is she going to need, and how is that going to like equal the money that she needs to buy the book? So it's how much money does she have? Well, she's got $5 bills, so $5 plus 7 dimes, which is 70 cents, plus 6 pennies, which is 6 cents. So all together, that's going to give me $5.76 plus what equals the $8. So she needs in total $8.47. So altogether, that's going to be $8.47 that she needs. So I'm thinking I know a part, I don't know the other part, and I know how, like, what is the whole? What does she need at the end altogether? So that tells me this is a subtraction problem. Now, we are not going to subtract in decimal form because that is a 5th grade standard. Some of you guys might be ready to subtract in decimal form, so that's great that you're already thinking like a 5th grader, but we're actually going to be solving in unit form here. So I'm going to turn this back into unit form. So we've got because we're trying to think, how much more money does she need? In order to find the missing part, I'm going to need to take this part away to get the second part. So I'm going to draw a tape diagram to help us visualize that. So I'm going to move all this stuff down. Move that down to draw us a tape diagram. All right, so tape diagram. What is the money that what part do we know? We know a part is the $5.76. What don't we know? We do not know how much money she needs to buy the book, like how much more money she needs. But we do know the whole, which is the total cost of the book, the total cost of the book. So the whole is going to be $8.47. So if we take away this $5.76, we will figure out how much money she needs to buy the book. All right, so back to solving in unit form. We've got we've got $8 because we're taking away from the total. We're taking away this part from the whole to figure out our other part. So we've got $8.47. cents minus $5, 76 cents. All right, so I'm going to subtract like units from like units. So I am going to need to subtract 76 cents from 47 cents. Now, if I was looking at this like a regular standard algorithm problem where I've got 47 cents and I'm trying to take away 76 cents, my smaller number is on the top. So that means that right now I do not have enough to be able to, I can't take away 76 cents from 47 cents because I don't have enough. So how am I going to get more cents to be able to subtract? Well, we have some dollars here. So we can actually take away $1, turn this into $7, and turn that $1 into 100 cents. So I can actually rename this as $7 and 147 cents, because it's like I took away $1 and I turned it, and the one that I took away, I turned it into 100 cents. So now, can I take away 76 from 147? Yes, I can. So I'm going to take my 147 cents and take away 76 cents from that. Okay, so if I took away 147 cents from, took away 76 cents from 147 cents, I got 71 cents. So I took away my 147 minus 76 cents, and I got 71 cents. Now, what about my dollars? I've got $7 minus $5, because remember, we did have 8, but I took $1 and turned it into 100 cents. So we now have $7. Take away 5, I'm left with $2. So what does that mean? That means that Miss Faulkner needs $2.71 to buy, to buy the book. That one was kind of tough because we had to know that we didn't have enough cents in order to subtract, and so we needed to borrow from our dollars in order to be able to subtract our cents amount. So hopefully that kind of helps us. It's kind of like when we subtract fractions, where if subtract mixed numbers, if we don't have enough to subtract, we borrow from the whole to get more fractional units. So this was just one way to solve. I'm going to show you another way to solve. Okay, so the second strategy that I'm going to show you is kind of similar to problem number 1, where we're going to like do some breaking apart. So if I've got $8.47 and I'm taking away $5.76 from that, I can break apart 76 cents into 47 cents and 29 cents, because 47 plus 29 gives me 76. So I can take the 47 minus 47 and just get 0. So I've got $8 minus $5, which is $3. And then I did 47 cents minus 47 cents, which is 0. So that would leave me with $3 minus 29 cents. And I would need to take my $3 and break it apart into $2 and 100 cents, so I could subtract my cents. So 100 minus 29 I don't have enough. I would need to bring this, borrow from my hundreds place, bring it over to my tens, turning this into a 10. I still can't subtract, so this 10 would turn into a 9, and then I would bring that over here. So 10 minus 9 is 1. 9 minus 2 is 7. So that gives me 100 minus 29 cents is 71 cents, and then I've got my $2 left over, so $2.71 is how much Miss Forkner needs to buy the book. Now, that might not have made sense to some of you. That's okay. It might have made sense to some of you, might not. So, like I said, that's okay. It's just another way to solve. Everybody's brains work differently and can think about things in different ways. So, like I said, if you understood the first strategy more than the second strategy, that's great, because it's not like I'm expecting you to solve both ways. It's kind of just solve in the way that makes the most sense to you, and this might make the most sense to somebody. So just so you know, more than one way to solve a problem. Let's go ahead and move on to question number 3. All right, so same thing. I'm going to have you try to solve this on your own, and then you'll pause the video, work it out, and then play it whenever you're ready to go over the answer and share strategies. So the question reads, Seiden has 8 dimes and 8 pennies. Emerson has $2, 4 dimes, and 2 pennies. Ella has $6 and 13 pennies. They want to put their money together to buy a game that costs $10. Do they have enough money to buy the game? If not, how much more money do they need? So this actually looks like you're going to answer 2 parts. It's either yes or no. Do they have enough money? And if not, you're going to need to answer how much more money do they need. So it's not just going to be a yes or no question. You might have to solve for the second part. So go ahead and pause the video and play it whenever you're ready to share and check your answer. All right, so if you have played the video, I'm guessing you are ready to go over the answer. So if I read the question again, Seiden has 8 dimes and 8 pennies. Emerson has $2, 4 dimes, and 2 pennies. Ella has $6 and 3 pennies. They want to put their money together to buy a game that costs $10. Do they have enough money to buy the game? If not, how much more money do they need? All right, so they're putting their money together to buy a game that costs $10. We're trying to figure out, do they have enough? So putting their money together, that means they're gonna put it all in one pile and count it all together and see, do they have enough money to pay for this $10 game? So that means we're probably going to figure out how much does each person have, how much do they have all together, and do they have enough? All right, so Seiden has 8 dimes. And 8 pennies. So 8 dimes, that's going to be 80 cents. 8 pennies, that's going to be 8 cents. So altogether, Seiden has 88 cents to put towards the game. So Emerson has $2, 4 dimes, and 2 pennies. So $2, that's $2. 4 dimes, that's 40 cents. 2 pennies, that's 2 cents. So all together, Emerson has $2 and 42 cents to add on to the game, or add on to their total amount. So Ella has $6 and 13 pennies. So $6 would be $6, and 13 pennies would be 13 cents. So all together, Ella has $6.13 to put towards the game. So altogether, how much money do they have? So I'm going to add like units plus like units. So Sidon doesn't have any dollars to add on, but Emerson has $2, Ella has $6. So I've got $2 plus $6 gives me $8. And then let's add our cents. So Sidon has 88 cents plus Emerson's 42 cents plus Ella's 13 cents. So all together, I'm going to do that off to the side. So that's 143 cents that they have. That is more than $1, because think 143 cents is 143 hundredths of $1. So we have more than $1 there. How many hundredths are equal to 1? That's going to be 100 hundredths, and I'm going to have 43 hundredths left over. This 100 hundredths is $1. So I'm going to add it on to the $8 that we already have. That's going to give me $9. And then my 43 hundredths, that's going to be the same thing as 43 cents. So this guy got turned into 43 cents. So altogether, they have $9.43. Is that enough to pay for the $10 game? No, it is not. So I'm going to say all together, they have $9.43. They do not have I guess I'm not going to write out they do not have enough, but I'm going to write instead how much more they need. So this is kind of like problem number 2, where you have to figure out, like, you have a certain amount of money, you need some more money to be able to pay for something, and we need to figure out how much more do they need. So that's going to be subtracting. So I've got $10 minus $9.43. I have enough dollars to subtract, but I don't have any cents that I can subtract from, because remember, I need to subtract like units minus like units. So what I'm going to do is I am going to break this apart into $9 and 100 cents, because now instead of $10, I've got $9 and 100 cents that I'm going to be able to subtract from my 43 cents to figure out how many more cents do I need. Oops. I can't subtract, so I need to borrow. I still can't subtract, so now I need to borrow from the tens place, turn that into a 9. All right, so that's going to give me 57 cents. So $9 minus $9 is $0. Because remember, I don't have $10 anymore. I've got $9 because I turned it into a 9 and 100 cents. And then my 100 cents minus 43 cents gave me 57 cents. So how much more money do I need? They need 57 cents more to buy the game. Okay. So I'm going to show you one more strategy, and that'll be the end of this video. All right, so final stretch of the video. So this is just assuming that we already figured out how much each of them have. And this strategy involves like starting with the $10 and then kind of taking away what everybody has, like a little bit at a time. So it's kind of like we've got $10 and we're subtracting Sidon's 88 cents. So it's kind of like we're doing minus 88 cents, which would give us, actually I probably don't want to do it in decimal form because we're not subtracting in decimal form, we're subtracting in unit form, so it would just be 88 cents, and that would leave us with $9 and 12 cents, and then from there we would subtract Emerson's amount, so that would be minus $2, which would give us $7, which would give us $7.12, and then we would subtract her 42 cents, in which we would have to kind of break this apart into $6 and 100 cents, which turns this into $6 and 112 cents minus 42 cents, which would give us $6 and 70 cents. And then from there we would subtract Ella's $6. So $6.70 minus $6, which would give you just 70 cents. And then we subtract the 13 cents that Ella has, and then we would get that 57 cents that we need to buy the game. Okay, and I know some of that, it probably was just like, that seems really complicated, but like I said, not everybody's brains like think about things the same way. Sometimes we can think about it multiple different ways. Sometimes it's harder for us to think about solving a different way, but just know that there is always multiple ways to solve a problem. There's probably more ways to solve other than what I just showed you here. So thank you for sticking through this really long video. If there's ever videos that are like 30 minutes long like these, I really encourage you to like take a break, get a snack, get a drink, like pause it like in between problems and kind of give yourself a couple minute breaks to be able to like kind of refocus and make sure that you're giving it the best that you can through the concept development, because then it's going to prepare you better for that problem set. All right, thank you so much for tuning in, guys. I hope you're doing well, and until next time, bye.